Have you ever looked up at the night sky and thought space was just empty? Well, get ready to have your mind blown, because it's not. The vacuum of space is actually a bubbling, chaotic sea of quantum fluctuations. Think of it as a constant, invisible storm of particles popping in and out of existence. For decades, scientists and science fiction writers have dreamed of harnessing this incredible energy. Imagine powering a starship, or even creating a warp drive, just by tapping into the fabric of space-time itself. While that might still be a distant dream, a concept that's gaining real traction is something called quantum energy teleportation. Now, hold on. I know what you're thinking. Teleportation? Like beam me up? Scotty, not exactly. We're not talking about sending people or objects across space just yet. What we're talking about is moving energy from one point to another without it having to travel through the space in between. It sounds like magic, but it's rooted in the bizarre and wonderful rules of quantum mechanics. To understand this, we need to first understand what's already been achieved. Quantum teleportation of information. You see, scientists have already successfully teleported information. They've done it over hundreds of kilometers. The way it works is by using a phenomenon called quantum entanglement. Imagine you have two particles, let's call them a bell pair, that are linked in a special way. No matter how far apart they are, if you measure a property of one particle, you instantly know the same property of the other. It's like having two coins that, when flipped, will always land on opposite sides, even if one is on Earth and the other is on Mars. Einstein famously called this spooky action at a distance. Using this link, physicists can transmit the quantum state, the information, of a third particle from one location to another, effectively teleporting that information. The original particle is destroyed in the process, and a perfect replica of its state appears at the destination. It's not a copy, it's more like a quantum fax machine. So, we can teleport information. But what about teleporting matter? Teleporting a physical object, like an apple or a person, is a whole different ballgame. The amount of information you'd need to scan, transmit, and reconstruct is astronomical. To teleport a single human being, you'd have to pinpoint the exact state and location of every single atom in their body. We're talking about more atoms than there are stars in the observable universe. The data required would be staggering, far beyond anything our current technology can handle. So, unfortunately, human teleportation remains firmly in the realm of science fiction, for now. But let's get back to energy. This is where things get really interesting. If we can teleport information using entanglement, could we use a similar process to teleport energy? Let's go back to our entangled particles, our bell pair. Imagine two scientists, Alice and Bob, each holding one of the entangled particles. Alice performs a specific measurement on her particle and a third particle she has in her lab. This measurement consumes a tiny amount of energy. Because her particle is entangled with Bob's, the measurement she makes instantly affects Bob's particle, no matter how far away he is. The theory of quantum energy teleportation suggests that, under the right conditions, the energy Alice used for her measurement could be extracted from the quantum vacuum at Bob's location. Let me break that down. Alice puts energy in at her end. Through the spooky connection of entanglement, Bob can pull energy out at his end. The energy doesn't travel through the space between them. Instead, it's borrowed from the local quantum vacuum at Alice's location and paid back from the vacuum at Bob's location. It's like a cosmic loan system where energy disappears from one place and reappears in another, with the quantum vacuum acting as the bank. It's a transaction that happens outside of our classical understanding of physics. This isn't about creating energy from nothing. It adheres to the law of conservation of energy. It's at simply moving it from point A to point B in a completely new and revolutionary way. What are the implications of this? They're enormous. Imagine future computer chips, where energy is teleported directly to the components that need it, eliminating the need for tiny, complex wiring and reducing heat. This could lead to a revolution in computing power and efficiency. Think about energy transfer on a larger scale. Could we one day power a Mars colony by teleporting energy directly from a massive solar farm on Earth? It sounds like pure fantasy, but the underlying physics is being seriously explored. Researchers are actively working on experiments to prove this concept. While the amounts of energy are currently minuscule, proving it's possible would open up a whole new frontier in science and technology. This concept forces us to rethink everything we thought we knew about space. energy, and reality itself. The universe is so much stranger and more wonderful than we can possibly imagine. The quantum realm is a place of pure potential, where the rules of our everyday world break down. Things can be in multiple places at once, and particles can be connected across vast distances. Harnessing these properties could be the key to unlocking the next stage of human civilization. From warp drives powered by vacuum energy to instantaneous energy transfer across solar systems, the ideas that were once confined to the pages of sci-fi novels are slowly but surely making their way into real-world laboratories. The journey to understand and control these quantum phenomena is just beginning. But every new discovery brings us one step closer to a future we can currently only dream of. The teleportation of energy is a perfect example of how the weirdness of quantum mechanics could have profoundly practical applications. It's a reminder that there's always more to learn, and that the universe holds secrets we are just beginning to unravel. We're going to be diving deeper into these mind-bending topics. In fact, we have a very special live stream coming up, where I'll be interviewing Dr. Matt Kaplan, an expert on black holes and theoretical physics. We'll be discussing how black holes grow, their relationship to the quantum vacuum, and so much more. You won't want to miss it. So, if you found this fascinating and you want to stay on the cutting edge of science, make sure you hit that subscribe button and turn on notifications. Thanks for watching, and as always, stay curious.